in classification, the concept of overfitting can be even stranger than it is in regression. Because here, we're not just predicting a particular value, a price of a house, or even whether a review is positive or negative, but we're often asking probabilistic questions, like what is the probability that this review is positive? So let's see what overfitting means with respect to estimating probabilities. So as you remember from the previous modules, we talked about the relationship between the score on the data, so that's W transpose H, which varies from minus infinity to plus infinity, and actual estimate for probabilities, the probability of y equals plus 1, let's say, given its input x and w, as a sigmoid applied to the score function W transpose H. So that's the model we're working with. And if you remember, as we see overfitting, we see W is becoming bigger and bigger, those coefficients becoming bigger and bigger and bigger and bigger, which means that W transpose H becomes huge, massive, and that pushes us either, if it's massively positive, to saying that the probabilities are exactly 1, really confident they're 1, or if they're massively negative, they're confident they're 0. So overfitting in classification, especially with logistic regression, can have really devastating effects. We can yield these really massive coefficients which push W transpose H, this score, to be very positive or very negative, which pushes the sigmoid to be exactly 1 or exactly 0. And so not only are we overfitting, but we're really confident about our predictions. We think that this is exactly a positive review when we should be more uncertain about it. So let's observe how that shows up in data. Let's go back to the simple example that we had before, where we're just fitting a function, a classifier, using two features, numbers of awesomes and number of awfuls. Let's say the coefficient of awesome is plus 1 and the coefficient of awful is minus 1. And we have an input, 2 awesomes, 1 awful. If you look at the difference between number of awfuls and number of awesomes, you have 1 here, because there's 1 awesome more than there's awfuls. And so the actual score that we get is 1, which means that the estimated probability of a positive review is 0.73 is probability review is positive. And I can live with that. You know, I have a review, it has 2 awesomes, 2 things were awesome about the restaurant, 1 thing was awful. You know, it's more than half probability of being a positive review, but not a lot more than half. Now if I take the same coefficients, nothing's changed, the same input, but I multiply those coefficients by 2, now I have 2 awesomes and, 2 awesomes, 1 awful, still as input, but the coefficients are plus 2 and minus 2. Now the curve becomes steeper. And so if I look at the same point, where the difference between awesomes and awfuls are 1, and I look at my predicted probability, now I've increased it tremendously. Now I see the probability of positive review is about 0.88. I'm even more confident that the same exact review is positive. So that doesn't seem as good, 88% chance that it's positive. But let's push the coefficients up more. Let's say that the coefficient of awesome is plus 6, the coefficient of awful is minus 6. Now if I look at the same point, the same input, the same difference between awesomes and awfuls, and I push that up, I get this pretty scary result. It says that the probability of being a positive review is 0.997. I can't trust that. Is it really a case that 0.997 probability that a review of 2 awesomes and 1 awful is positive? That doesn't make sense. So as you can see, we have the same decision boundary, still crossing at 0. The coefficients are just getting a bit bigger every time, but my estimated probability of the review becomes steeper and steeper, more and more likely, which is another type of overfitting that we observe in logistic regression. So not only the curves become weird and wiggly, but the estimated probabilities become close to 0 and close to 1. So let's look at our data set and see how we observe the same effect right there.